Question 3. Determine the points of intersection of the circle x squared plus y squared minus 4x plus 6y plus 8 equal to 0. So this is circle equation. And the line y equal x minus 6. So of course we're going to solve by substitution. So we're going to substitute y equal x minus 6 into the curve, into the circle equation. So we have x squared, and of course we're replacing the y now with x minus 6. So y squared becomes x minus 6 squared, all square, minus 4x, and 6y becomes 6 times x minus 6. So replacing the y with x minus 6 plus 8 equal to 0. So we'll try and expand the bracket now and simplify. Let's expand the bracket. So we have x squared. This bracket is x minus 6 times itself. That's x squared minus 12x plus 36. So we expand that. And we have minus 4x plus distribute the 6. So 6 times x, that's 6x. 6 times minus 6, that's minus 36 plus 8 equal to 0. So we attempt now to group the like terms. So we have x squared, and here's another x squared. So we have two x squared terms. Grouping the x's, we have minus 12, minus 4, that's minus 16x, plus 6, that's minus 10x. Grouping the constants, that's 36, cancel with negative 36, so we are just left with positive 8. And of course, we can divide through by 2, since all these values are even, so we can divide through by 2, we'll get x squared minus 5x plus 8 divided by 2, 4. And this is a straightforward factorization. This is x minus 1, x minus 4 equal to 0. To solve, we equate both factors to 0. So x minus 1 equals 0, or x minus 4 equals 0, which means x is equal to 1. Over here, x is equal to 4. Now to get the corresponding y value, we know that y equals x minus 6. So we can just substitute each x value into y equals x minus 6. So if x is equal to 1, then y would be equal to 1 minus 6. That's negative 5. And if x is equal to 4, then y would be equal to 4 minus 6, which is negative 2. So the points of intersection, for the line and the circle are when x is 1, y is negative 5, and when x is 4, y is negative 2. So B part 1, given that the coordinates of the point A and B are 7 minus 3 and 2, 1 respectively, state the position vectors corresponding to the points A and B in the form xi plus yj. So position vectors is just what you have O in front. So position vectors are OA, same as the coordinates. A, 7, this is A, right? 7 minus 3, so 7i, 7 for the x, and the y is negative 3, so minus 3j. And OB, 2i, x is 2, and y is 1, so 1j. So 2i plus 1j, 1j is same thing as j, right? Determine AB, so the vector AB, we can just reverse subtract, so the vector AB is B minus A. So B, remember B was 2, 1, A is 7, negative 3. So B, 2, 1, minus a, and a is 7 negative 3. So subtract 2 take away 7, that's negative 5. 1 minus minus 3, that's 1 plus 3, that's 4. So in the form it's in the form we're asked to write it, ij xj plus yi. So this would be the form xi yj. So the x negative 5, so it's negative 5i plus 4j. In that form, in column form, it's negative 5, 4. Calculate the value of a scalar product OA times OB. So OA times OB. So OA, what was OA again? OA same as A. OA 7 negative 3 and OB 2, 1. So 7 negative 3 times 2, 1. So 7 negative 3 times 2, 1. The scalar product, or we call it dot product. So 7 times 2, that's 14. Plus negative 3 times 1, that's negative 3. So that's 14 minus 3, that's 11. Using the letters P, Q, R, write an expression for each of the following trigonometric ratios. We have a right angle triangle there. Hypotenuse Q, opposite to theta, that's P. Adjacent to theta, that's R. So sine, we know the ratios are SOHCAHTOA. So sine is opposite over hypotenuse. So sine theta, the opposite is P. The hypotenuse is Q. Cos theta, that's K, adjacent over hypotenuse. The adjacent is R, and the hypotenuse is Q. Using your answers in C part 1, determine the value of sine squared theta plus cos squared theta. So sine squared theta plus cos squared theta. So sine squared just sine theta all square. Likewise, cos theta is cos theta all square. So remember, sine theta was P over Q, cos theta was R over Q. So sine theta was P over Q, cos theta was R over Q. So P over Q all square, cos theta was R over Q all square. So this is P square over Q square plus R square over Q square. And since we have a common denominator, then we can just have one common denominator, which is Q square. Put the numerators together, that's P square plus Q square. So it's P square plus Q square all over Q square. Part D, prove the identity that tan A plus 1 over tan A equal 1 over sine A cos A. So let me begin from the right hand side, which has more terms. So right hand side, RHS, abbreviated right hand side, that's tan A, and tan A is sine A over cos A. This is the reciprocal of tan A. The reciprocal of tan A is just the cos A over sine A. So we can put the numerators together, the denominators together. So that's cos A times itself, so that's sine A times cos A. And then to get the numerator, we can just cross multiply. So that's sine square A, sine A times sine A, plus cos A times cos A, that's cos square A. Now the Pythagorean identity says that sine square plus cos square is 1. So this is 1 over sine A times cos A, and you'll observe this is what the right hand side is, 1 over sine A cos A. So this is the right hand side. So we have shown the left hand side simplifies to give the right hand side. So therefore this proof was easily done. Let's move on to question 4. use the definition of the derivative as a limit to find f prime x, same as dy by dx, for the function f of x equal x squared minus 3. So the definition, f prime x, derivative of the function, is a limit as h approaches 0 of f of x plus h minus f of x all over h. Let's continue. So a limit as h approaches 0. So f of x plus h, we simply go to the function f of x and replace the x with whatever is in the bracket. So f of x plus h is x plus h square minus 3 minus f of x, and f of x is x squared minus 3. So it's a straightforward substitution all over h. And we don't want to substitute the h as yet, simply because we'll get divide by 0, which is undefined. So let's not divide yet by h, by 0. So let's expand the numerator. So x squared, x plus h all squared, that's x squared plus 2xh plus h squared minus 3. Distribute this is minus x squared plus positive 3 all over h. And what's that now? X squared cancel with negative x squared. Negative 3 cancel with positive 3. So what we have, we can factorize h in the numerator. So limit h approaches 0. In the numerator, we factor out h. We'll have 2x plus h. In the denominator is just h. So h divided into h, leave what's 1 in the numerator, in the denominator. And of course, we can sub now 0 for the h. If we sub 0 for the h, we're left with just 2x over 1, which is just 2x. So the derivative of the function x squared minus 3 is just 2x. Now, f double prime is the second derivative. So we get f double prime x. By differentiating 2x, we end up with 2. And the 5 here will become irrelevant because there's no x value to substitute with the 5, so the solution is just positive 2. Part B, given that y equals sin x over cos x, show that dy by dx is 1 over cos square x. Alright, so y equals sin x over cos x. We're going to differentiate by using the quotient rule. So the quotient rule says differentiate the numerator. So differentiate sine, you get cos. So differentiate the numerator times it by the denominator. So it's cos times the denominator, which is cos. So cos times cos, that's cos squared. Minus, we're going to differentiate now the denominator. Differentiate cos, you get negative sign. So it's actually minus sign. And we times this now by the numerator, we end up with sine times sine, which is sine square x. All over the denominator square. So that's cos square x. So again, differentiate the numerator, and whatever you get, you multiply it by the denominator. That's how we get the cos square. Minus, differentiate the denominator, and whatever we get, we multiply it to the numerator. Alright, so we end up with cos square minus sign. But the double negative, minus, this becomes actually plus. And we know the Pythagorean identity says that cos square plus sine square is 1. That's 1 over cos square x. That's that. Part C, the equation of a curve is given by y equal that. Determine the equation of the gradient of the curve. So the gradient, we're going to differentiate this using what we call the chain rule. So the chain rule says multiply by the power, restate your bracket, subtract 1 from the power, we end up with positive 3, and you form a new bracket, and in this new bracket we'll differentiate the original bracket. Differentiate 5x squared, that's 10x, differentiate negative 7r any constant, that's 0. So we end up with the 4 times the 10x will give us 40x, and the bracket 5x squared minus 7 to the power of 3. That's the best we can do with it. Question 5.